we have seen the problems based on the Bayes theorem, and it was very happy. I felt very happy that one of the students posed a question on the previous problem discussed, and let us see the problem again, because it is little lengthy. Because of shortage of time, we could not discuss the problem properly today. Let us work out the same problem again. Now, please go to the slide. The problem is, during a power blackout, 100 persons are arrested on a suspect of looting. Each is given a polygraph test. You might be knowing the polygraph test. In a movie, you might have remembering in a Telugu movie, if you remember Brahmanandam and Ali, if you see a particular movie, that polygraph is used. If somebody says, if somebody lies, then it says he's lying. If somebody is telling truth, it doesn't say anything. So that is nothing but a polygraph. So polygraph test, from past experience, it is known that the polygraph is 90% reliable, which when administered to a guilty person, and 98% reliable when given to someone who is innocent. Okay, now suppose that of the 100 persons taken into custody, only 12 were actually involved in any wrongdoing. 12 were actually involved in any wrongdoing. If the probability that a given suspect is innocent, given that the photograph or polygraph says he is guilty, is A by B, where A and B are relatively prime, find the value of A plus B. This is what given. So for the purpose to avoid confusion, I'll tell you a method to apply the Bayes theorem. It will be better for you. Like, whatever the event is needed, let it be A first. Like what? A is finding guilty. Finding guilty of what? Finding guilty through polygraph test. Okay. Now, this finding guilty can happen in two different ways. Whatever the problem it is, take the required one as A, and in how many ways it is happening, take that as different branches like this. Because in this case only two branches are there. One is innocent, another one is really guilty. One is innocent, other one is really guilty. Okay, so there are only two cases, but you may have three also. Tomorrow, in the tomorrow session, we will discuss the mixed problems. In that one, I'll take some more problems on Bayes theorem also, because today we have to discuss more on theoretical distributions, that is probability distributions. Okay, now let us take these two as B1, B2. What is B1? Really guilty. Really guilty. The event of getting really guilty. What is B2? Innocent. Now, see the data again. How many, if 100 people are chosen, how many are really in wrongdoing? Please see that one. In the slide, only 12 were actually involved in any wrongdoing. Only 12 were actually involved in any wrongdoing. What does it mean? Probability of B1 is given to be 12 by 100. Then what should be the probability of B2? Obviously, it is 100 minus 12, 88 by 100. It's clear, I think. Now, what is the probability of getting a person who is really guilty and he is found to be guilty? The person is a wrongdoing person and he is found guilty. That means it is in both the ways it is real. In both the ways it is real. That is probability of getting guilty for B1. What should it be? Probability of getting Guilty with B1. What is B1? Guilty person. What is it given there? You can see that it is, if you go to the third sentence, polygraph is 90% reliable. 90% reliable with a guilty person. Isn't it? It is known that the polygraph is 90% reliable when administered to a guilty person. So, it is 90 by 100. It is 90 by 100. And what is the probability that an innocent person is found guilty? What is the probability that innocent person is found guilty? Understand it carefully. So, if you go through the same sentence, 90% reliable when administered to a guilty person and 98% reliable when given to someone who is innocent. It is 98% reliable when it is given to an innocent person. That means it goes 2 times wrong. That is 2% wrong. It goes 2% wrong means it is 2 by 100. So might be yesterday we might have taken 98 here in a hurry, but understand that who asked the question, just you take a look at it. I don't know the name of the person who asked this question. I'm very happy you follow the lesson carefully and you will be learning all these things very easily. Like here, because we want the innocent person to be guilty and it is 98% reliable. Polygraph is 98% reliable, so it is 2% wrong. So, getting an innocent person guilty is 2 by 100. Now, what we require is, you can see the last sentence and the polygraph, if the probability that a given suspect is innocent, given that the polygraph says he is guilty, is A by B, where A and B are relatively prime numbers. And find the value of A plus B. Given that innocent person, isn't it? Wrongdoing, if the probability that a given suspect is innocent. Given suspect is innocent means this A must occur with B2. This A must occur with B2 is given by, it is now you can write directly. It may happen with B1. What is the probability to happen with B1? 12 by 100 into 90 by 100 plus 88 by 100 into 2 by 100. What is our requirement here? This one is our requirement. So, this is a favorable probability, this is a total probability, and this is a favorable probability. Favorable probability is 88 by 100 into 2 by 100. This is a required probability. It is given to be what? It is given to be A by B. You can go to the question. It is given to be A by B. So, please see this one now. If you take LCM, this will be getting cancelled. And what else is remaining is 88 into 2 upon 12 into 90 plus 88 into 2. You take something 8 common and simplify this. What will you get? You can check it out. It should be, I think, 22 upon 157. If I remember the answer well, it should be 22 upon 157. And it is given to be A by B, where A and B are relatively prime numbers. What is the meaning of relative prime numbers? The GCD of these two numbers is 1. The GCD of these two numbers is 1. What is GCD? How to find out GCD? If you go to your lower classes, is 157. Divide with 22. 22 8s will be more. 22 7s 14. 14 plus 1 15. It is 3. It is 21. 22 again. 22 again is to be divided with the remainder. So how many times it goes? 7 times 21. 1 and 3. It is 3 times. Now 0. This is nothing but GCD. This is nothing but GCD. So whenever the GCD of two numbers is 1, then these two numbers are said to be relatively prime numbers. Relatively prime numbers. What should be a plus b now? It is 97179. You see the options there, please. It is third option. It is 179. Okay. Now, that's all. I hope your doubt now cleared. It is 22 upon 157. So whenever you attempt the problems on Bayes' theorem, split it like this. Of course, we'll be working out more and more problems in the next session, and in the next session, that is tomorrow's session, we'll be working out only the problems, because today the entire theory will be finished. Okay, now let us see the theoretical distributions. Theoretical distributions, that is probability distributions, I can say. That is probability distributions. First of all, you think of it. What is the distribution of the probability? Why should we distribute the probability? You might have remembering, if it is CBSE, I think you have statistics in your 11th class itself. In that one, you might have done the problems based on frequency distribution. Frequency distribution. If you remember well, this is tally marks. We will write tally marks, class interval, tally marks. Do you remember? This is tally marks. Basing on tally marks, we write the frequency. So this is class interval is 0 to 10, 10 to 20, like that you used to write. Okay, these tally marks are used like this to count the frequency. So the frequency is 2, 7, 5, 7, something like that. What does it mean? Let us take your class. Your class is consisting of 50 students. In the 50 students, we want to know how many students have got 0 to 10 marks, how many students have got 10 to 20 marks, how many students have got 20 to 30 marks, and how many students have got more than 60 marks, how many students have got more than 90 marks, something like that. If the class teacher wants to have a look at the entire data at random, then he or she need not have to go through the entire data of all the 50 students. At a glance, he can see this. This is nothing but frequency distribution you might have learnt in your lower classes. Similarly, it is nothing but the probability distribution. What is the probability distribution? And what is the total probability? Probability never exceed 1, you know that. Probability will never exceed 1. That means this 1 is to be distributed. Understand the probability distribution like this. This is 1. Why 1? Because you can see the sum of the probabilities, and the value of the probability always lie between 0 and 1. We discussed it in the first class itself. That is 0 less than or equal to P of E. That is any event is less than or equal to 1. We discussed that. P of E is 0 is impossible event. P of E is equal to 1 is a certain event, and all the remaining values fluctuate between 0 and 1 only. Okay, so maximum value probability is 1. Now this 1, how it can be distributed in a sample space, we are interested in that one. So what I do now, I'll take a coin and I'll toss the coin for 3 times. I'll toss the coin for 3 times. And my expectation or my success or our success, let us take, is getting a tail. Getting a tail is our success. How many times the coin is tossed? 3 times. 3 times. When a single coin is tossed, you are getting 2 outcomes. What are they? Head or tail. That is 2 outcomes are there with each trial. How many trials are made? 3 trials are made. This is first one 2, second one 2, third one 2, 2 into 2 into 2. How much is it? 8. So totally 8 outcomes. You will have your sample space consists of 8 outcomes. If you conduct the experiment for 3 times, that is tossing a coin. So let me write all the outcomes now. Head, head, head. Head, head, tail. Head, tail, head. Tail, head, head. Tail, tail, head. Tail, head, tail. Head, tail, tail. And tail, tail, tail. 1, 2, 3, 4, 5, 6, 7, 8 are there. Totally 2 cube outcomes are there. 2 cube outcomes are there. What is our success here? Getting a tail is our success. Getting a tail is our success. 0 successes. Let me write in each of the outcomes our success. Our success is nothing but getting a tail. It is 0. And in this case, it is 1. It is 1. It is 1. It is 2. It is 2. It is 2. It is 3. You understand what I'm saying here? In each of the outcomes, it's nothing but a sample space, I say. Sample space. The sample space for each of the outcome, if I contribute or attribute the successes, number of successes to each of the outcomes, in this case it is 0, in this case 1, 1, 1, 2, 2, 2, and in this case all are successes. So you can understand the success is randomly varying. The success is randomly varying from each of the from outcome to outcome. The success is randomly varying from outcome to outcome. Understand that. So that random variable is generally denoted by capital X. Understand. Because getting success is randomly varying from outcome to outcome, it is named as random variable. Simple understanding. So, how success is varying now? How success is randomly varying? Sometimes you are getting 0, sometimes you are getting 1, sometimes you are getting 2, sometimes you are getting 3. Okay, now here our random variable is getting tail. Getting tail in each of the outcomes. In each of the outcomes. So, now let me write probability of this random variable, P of X equal to Xi. And as you know, so far we have discussed how to write the probability. Number of favorable outcomes whole divided by total number of outcomes. Number of favorable outcomes divided by total number of outcomes. 0 successes, only 1. So favorable is 1 and total is 8, 1 by 8. Getting 1 success, favorable or 3 and total is 8. Getting 2 successes, favorable or 3, total is 8. Getting all successes, it's only 1 by 8. See how this 1 is beautifully distributed with each of the random variable. How can you say that it is 1? Add all this. Add 3 plus 1, 4 plus 3, 7. 7 plus 1, 8. 8 upon 8, 1. 8 upon 8, 1. So this 1 is beautifully distributed in each of the random variable. The sum of the probabilities, you can clearly see that it is 1. Whenever you are not getting the sum, 1, take it as granted you have gone wrong in writing the probability. Take it as granted that you have gone wrong in writing the probability. So, like this, the probability is distributed to each of the random variable. So now, what we do, we will generalize this. I have taken a better example to explain you how the probability 1 is distributed to each of the random variables. So, understand. Now, how can we generalize this? How can we generalize this to any event? How can we generalize this to any event? First of all, what you have to understand, the sum of the probabilities, simply I will write it as P of X is equal to Xi, let me say. I may run from 1 to n events we have taken. Sum of the probabilities, n number of random variables are there. N number of random variables. It is equal to 1. Understand? Now, number 2, mean. You might be remembering in frequency distribution, also you have sigma fx upon sigma f. Sigma f into x upon sigma f is you have done in your lower classes to find out the mean using frequency. But this sigma f, you know, what is sigma f? Sum of the frequencies. That is already placed here. It's already placed here. Total number of outcomes is placed here. That is why you don't get this. You don't get this. So that is why mean becomes sigma x into, for the better understanding, I will write it in this way to remember it easily. Sigma x into P of x. Sigma x into P of x is nothing but the mean, which is denoted by mu. Which is denoted by mu. What is the mean here now? 1 into 0. 0. Sorry. This is 0 into 1 by 8. Mean. Multiply this. Multiply this. Multiply this. Multiply this. 0, 3, plus 6, 9, plus 3, 12. 12 upon 8. 12 upon 8 is nothing but 3 by 2. So, in this case, mean is nothing but 3 by 2. Understand that? Understand that? So, mean is denoted by mu in this case. Now, third one is variance. Is generally denoted by sigma square. Sigma square. So, the sigma square you can understand will be like this. Sigma x square into P of x minus mu square. I'll show that here. This is 0, 1 by 8. Now, sigma x square means 0 square into 1 by 8, 0 only. This is 1 square into 3 by 8, that is 3 only. 2 square into 3. This is 3. This is 4 into 3, 12. 12 plus 3, 15. 15 plus 3 square into 1. 15 plus 9. It is 24. 24 upon 8 is this value. 24 upon 8 is this value. And we have already find out mu. What is mu? 3 by 2. So, 24 upon 8 minus, this is something like 3 by 2. You can understand now. Whatever it is. Understand the procedure. So, variance is denoted by sigma square. It is nothing but sigma x square into P of x minus mu square. It is very much related with the statistics, frequency distribution, which you already did. It is now the same, is extended to the theory of probability. Similarly, the standard deviation. What is standard deviation? It is simply sigma. It is sigma square. It is sigma. Means what? Square root of variance. These are the things you have to remember. Let us revise. Sum of the probabilities is 1. Mean mu is equal to sigma x into P of x. Random variable into their corresponding probability multiplied and added to give you mean. Next is variance. Sigma square is nothing but sigma x square into P of x minus mu square. It is squared. The difference is it is squared. Minus mu square. Standard deviation is sigma. Square root of this variance. These are the 4 terms you have to remember. This is nothing but the probability distribution. Then you might be thinking like this. So if the number of outcomes are very less, like I have prepared a table for 8 number of outcomes. I have prepared a table for 8 number of outcomes. If the number of outcomes are 8, the random variables in that case are 0, 1, 2 and 3. How many are there? 4 are there. 0, 1, 2, 3. So 4 random variables are there. It is easy to prepare a table for 4, even 5 or 6 or up to even if 10 is also greater value to prepare a table. So in such a case, what to be done? What to be done? Then the case of binomial distribution comes. What is this binomial distribution? Think of it practically. Don't see as a formula or whatever it is. Think of it practical. If the number of outcomes are less, then we can prepare a table and we can apply this formula when the number of outcomes are more. More in the case, it is generally up to 30. For binomial distribution, up to 30. And after binomial distribution, you have Poisson distribution also, which is of course not there in the IIT syllabus, but you have that Poisson distribution in your board level, board syllabus. So our board syllabus consists of more than that is given in IIT level. Understand? So where to apply the Poisson distribution and where to apply the binomial distribution, where not to apply the binomial distribution. These are the things if you understand. If you understand, you can easily solve the problems. Okay, so whenever the number of outcomes are less and it is easy for us to prepare a table, then it is convenient for us to work out through what I have explained in the previous problem. But whenever the number of outcomes are more, what I said, generally the sample up to 30. Sample means sample space is up to 30. Then in such a case, apply binomial distribution. If the number of outcomes are more than 30, then what to be done? What to be done? Then you have to go for this distribution. What I said, which is not there in our syllabus, is in IIT syllabus, but you have this in your board syllabus, Poisson distribution. So I'll make you understand where these are to be applied. The binomial distribution, you have taken a die and you have thrown the die for 20 times. You have thrown the die for 20 times. And you need the number of how many times number 3. What is the probability of getting number 3? Repeat. I have taken a die and thrown it for number of times. How many number of times? 20 times I have thrown. So if I throw the die for 20 times, I am interested in getting number 3 for, let me say, 7 times in 20. In 20 times when the die is thrown, I'm interested to get number 3 7 times in 20 times. Then in such a case, which one is to be applied? You cannot prepare the big table for that one. In such a case, you have to apply the binomial distribution. So where to apply the Poisson distribution? Poisson distribution will be like this. Let us take Hyderabad. Hyderabad is consisting of, let me say, 30 lakhs of people. In 30 lakhs of people, today, I want to know the number of deaths occurred. But I'm interested to know the number of deaths occurred due to snake bite. Let me say, today in Hyderabad, among 30 lakhs people, let me say, number of deaths occurred or 100. My N is 100. Let me say, today 100 people passed away in Hyderabad on this particular day. And what is my need here? The number of people died due to snake bite. It's not possible. May not be possible in Hyderabad, like a place, it is a city. It's a metropolitan city. You will not have deaths in this area due to snake bite. So let me say my probability of success probability, I have taken it to be P. So my probability of success almost tends to 0. I'll not get it. But what I'm doing now I'm taking in and around areas of Hyderabad. That is, I'm extending my domain to surrounding places wherein the village is also considered. villages also considered, like Nagar, Adilabad. You have different districts in and around Hyderabad. Then these villages are also included. Then there will be farmers going to the field, their agriculture, and in such a case, you may be getting a death due to snake bite. That means what happens? My domain is to be increased. If you take Hyderabad, only 30 lakh people are there. If you include the in and around villages, you will be getting 40 lakh people. So to get something to your success, you have to expand your domain. In that case, how to understand this? Your number of trials are tending to infinity and your success probability is tending to 0. Your number of trials are tending to infinity and your success probability is tending to 0. So what happens in this case? N into P under the limiting conditions exists. Infinity into 0. Infinity into 0 is said to be the indeterminate form. So this indeterminate form exists under the limiting condition. That means the success probability in this case is very less, very, very less. So to apply Poisson distribution, for a better understanding I'm applying, I'm explaining you this. To get this success probability when n is tending to infinity and p is tending to 0, you have to make use of the Poisson distribution. That is why for Poisson distribution, the expansion to be taken is an infinite series. If you remember well, we will take e power x expansion for Poisson distribution. But for now, you don't have this in the IIT level, the IIT syllabus. Just for the understanding's sake, I explained you that at the board level, but for the moment, as far as IIT syllabus is concerned, you have binomial distribution. So now, how to write the binomial distribution? Now, I have taken n trials. What are n trials here? Now, n trials means I have taken a die and I have thrown it for 40 times. N trials. What I said, getting number 3 is my success. So what I'm doing, P, probability of success. If you remember this, I will erase this, I'll write that more clearly. So what are we discussing now? We are discussing the binomial distribution. Okay. What I said, if the number of trials are more, generally a sample space of up to 30, then we have to make use of binomial distribution. What I'm doing now, I'm conducting n number of trials. In n number of trials, I have taken P, probability of success, Q, probability of failure, such that P plus Q is equal to 1. Understand? This is in one trial. Don't forget. Not in all the trials. This is in one trial. What does it mean? Getting a number 3 and throwing a die once. Getting a number 3 and throwing a die once is 1 by 6. Getting a number which is not 3 in throwing a die is nothing but 5 by 6. This I termed as P. This I termed as Q, such that sum is nothing but 1. Okay. Now, this is what I have taken to generalize a formula, to derive a formula. Okay. That is, I have conducted n number of trials and P is the probability of success in one trial and Q is the probability of failure in one trial. Understand? Such that P plus Q is equal to 1. Now, how many trials are conducted? N number of trials are conducted. So, to derive the formula, understand, let us split into operations. whatever it is, permutations and combinations, probability, whatever it is, if you split the problem into operations, that will be more comfortable to you. So what I'm doing now, I'm interested in number of successes now. How many number of successes? Let me say I have got X number of successes. And obviously n minus x number of failures will be there. Why? Because you have total number of trials are n, number of successes are x, and remaining are failures. Okay. Now, when I conduct an experiment for 30, 40 times, let me say, throwing a die, getting a number 3 may happen in the first trial, or may happen in the second trial, or may happen in the third trial, or may happen in the fourth trial. That means getting success may happen in the first trial or failure. The second trial, it may be a success or may be failure. The third trial, it may be success or it may be a failure. But how many total number of successes I have? X number of successes, such that sum of this is nothing but n trials. So my X number of successes are distributed throughout the 40 number of trials. My X number of successes are distributed throughout the 40 number of trials. That means in the first trial, I may get success or I may get failure. In the second also, I may get success or I may get failure. That means this X is distributed throughout the n trials. Understand? Distribution, selection comes under combination. Whether it is distribution or selection, it comes under combination. So how many number of trials are there? N number of trials are there. How many successes are there? X successes are there. So these X successes can be distributed among the n trials in how many different ways? NCX different ways. This is the first operation I'm performing. What I did, I have distributed all number of successes through n number of trials. And second operation, what I'm doing, the probability of a failure in one trial is nothing but Q. But how many failures you have? N minus x failures. So n minus x failures, each trial has a probability of Q failure. So for n minus x, you will have Q into Q into Q into so on. How many times? N minus x times. So what should it be? Q power n minus x. This is the second operation I performed. This is the first operation I performed. This is the second operation I performed. The probability of failure. And third operation, what I'm performing is the probability of getting success. You can imagine, why are you multiplying, sir? You may ask me. Why are we multiplying? I'm asking you the same question. Why are we multiplying? Because the principle of counting, which we have learned in the first class. This and this and this and this and means into, you have to multiply. Similarly, this one also, the P number of successes are there. There is nothing but P into P into P into so on. How many times you have this? X times, which is nothing but P power X. So how many operations do you have here? 3 operations. First operation, second operation, third operation. All these operations, one after the other, are simultaneously can be performed in NCX into Q power n minus x into P power x. Different ways. What is it? The probability of X successes is nothing but NCX into Q power n minus x into P power x, which is resembling the general term in the binomial theorem, NCX. Understand the terms first while doing the problem. N is the total number of trials and X is the number of successes, and Q is the probability of failure in one trial. Q is the probability of failure in one trial, and P is the probability of success in one trial. So what are the terms you must know here? You must know the number of trials, and you must know the number of successes. You must know the probability of failure in one trial. You must know the probability of success in one trial. Then you can apply this formula. And how do you understand this? Now you expand this. If you expand this, the final formula I have derived, you can understand. Now, you want 0 successes. You want 1 success. You want 2 successes. You want 3 successes. You want all successes. So, 0 success is nothing but NC0. into q power n minus 0 into p power 0 and plus nc1, one success, nc1 q power n minus 1 into p power 1, two successes, nc2 q power n minus 2 p square, and so on. How many successes? N number of successes, and so on. P of x equal to n. What is the last term? nc n into q power 0 into p power n. So if you add all this, 0 successes, 1 success, 2 successes, and so on, all successes. This is nothing but the binomial expansion, understand that, which is nothing but q plus p whole power n. But what is q plus p? You know, it's sum of the probabilities of occurrence and non-occurrence is always equal to 1. So it is 1 power n, which is nothing but 1. Whatever you do, the probability 1 is distributed like this. How is it distributed? Into 0 successes, 1 success, 2 success, 3 success, all successes, whatever we do. So for the sake of the number of trials, if the number of trials are more, then we make use of this binomial distribution. Okay, so in this one also, you understand, whenever you want to apply this formula, what are the terms to be known? Number of successes, number of trials conducted, the probability of failure in one trial, the probability of success in one trial. You must know this. Now, from this also, for this also, you have mean defined to be NP. What is N here? Number of trials. What is P? Probability of success in one trial. And variance. It's also easy. The board level also, you don't need the proof of it, just to understand. Variance NPQ. Obviously, standard deviation, what I wrote previously, standard deviation is root NPQ. These are the terms you have to remember. This is a basic formula. The probability of x equal to x is nc x into q power n minus x into p power x. And variance is NPQ. Mean, of course, is NP. In the previous case, it is represented with mu. Mu is there. It is sigma x into p of x. And here it is n into p. Variance is NPQ. There also, you have sigma x square into p of x minus mu square. And standard deviation, of course, is always square root of variance. So whenever you want to find out standard deviation in any distribution, then you have to find out all this. If standard deviation is asked, then you must know variance. To find out variance, you must know mean. Not in this case, but in the previous case. But in this case, if you know NPQ, then you can find out all these terms. So this is nothing but the binomial distribution. Let us feel more comfortable by applying this concept to the problems now. Let us go to the slide. Yes. A random variable. Let us take a lively problem first. The first problem, you can see it's a previous IIT problem. I'll give you the hint to work out. You work out that and come out with a solution. We will be discussing in the next class. If you get doubt, very simple. Please go to the first problem. A random variable x has the range 0, 1, 2 and p of x equal to 0 is equal to 3k cube, p of x equal to 1 is equal to 4k minus 10k square, p of x equal to 2 is equal to 5k minus 1, then k is equal to, what is the range there? 0, 1, 2. And each random variable probability is given. What is the first one we have learned? What is the first concept we have learned? It is nothing but the probability distribution. What is probability distribution? What is probability? Probability is always 1. What is 1? Its maximum value is 1. It will never exceed 1. So this 1 needs to be distributed. So in this case, now that 1 is distributed. What does it mean? That 1 is distributed between 0, 1, 2. So sum of the probabilities is equal to 1. What you have to do then? P of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 is equal to 1. is equal to 1. So what will it be? 3k cube plus 4k minus 10k square plus 5k minus 1 is equal to 1. Simplify that. You'll be getting a cubic equation. To solve the cubic equation and get the values of k for a cubic equation, you'll be getting 3 values for k, but all the 3 values of k will not suit or will not satisfy the definition of probability. That is why you have to choose a suitable value for k, and the options you can note down that 2, 1 by 3, 2 by 3, 1 by 9. It's a standard problem. You can get this problem in any book, any standard book. It contains the problem. Next one is for a dealer. Please work out the first problem, and if you get doubt, you have always, you can email your doubts info@kabtv.net. Please mail your doubts and we'll be answering very happily. And if you go to the second problem, for a dealer in a consignment of umbrellas, the probability of getting a profit of rupees 1500 is 0.6. Profit of getting 1500 is 0.6. The probability of getting a loss of rupees 1000 is 0.3. When he gets loss, generally in the summer, if those who have beauty conscious, the ladies generally, they use even in the summer also umbrellas. Generally they will have less sales in summer and they will have more sales in the rainy season, obviously. So in the rainy season, the umbrella seller will have more profits. In the other seasons, let us suppose you will have loss. So of getting a loss of rupees 1000 is 0.3, and the probability of getting a no profit or no loss is 0.1. No profit or no loss is 0.1. Let us take it as summer. Okay. The mean profit of the dealer is. How do you see this problem? It's a practical problem. What I'm saying, this type of problems are not limited to your 11th or 12th classes. You'll be getting later also whenever you are going to give a campus selection in your 3rd year or 4th year. The recruiters or the companies may ask you questions related to, they are asking the questions based on permutations and combinations and probabilities, a general topic, not a topic which is related to calculus. That is why it is placed even in this topic is read by even commerce students also, because after your B.Tech, if you go for CAT, there's IIM's examination, then also you may be getting these questions. So this is a very important topic, PNC and probability, which improves the logical reasoning of the students. So now in this case, let us take the profit with plus and let us take the loss with minus. What is plus there? 1500. What is minus there? Loss of 1000. That is minus 1000. Loss is minus. And no profit, no loss is 0. No profit, no loss is 0. This is our random variable here. And what is the probability given in this case now? Table prepared beautifully. 1500, getting profit is 0.6. Getting loss is given to be 0.3. Getting no profit, no loss is 0.1. He needs a mean. Beautifully framed. You'll really enjoy doing this type of problems if you understand the theory properly. So the mean, it is sigma x into p of x. Okay, this is x, this is p of x. So 1500 into 0.6. 15.6 are 90. That point is there. So 900. It is 300 minus 300. It is, of course, 0. 900 minus 300. 600. So throughout the year, if you calculate the profit of that seller who is selling umbrellas, his profit, average profit is 600. That means in a particular season he is getting profit, in a particular season he is getting loss, and in a particular season no profit, no loss. The average profit is given to be 600 rupees, like that. This distribution can be generalized even to commerce also, and you can work out these problems very easily if you go through the theory and properly if you understand the theory.